Okay, and we're live here. So this is our virtual fest, the Glenside Computer Club and the CoCo Nation doing a virtual computer fest run up to most of the fests that are coming this year, except for the one in Southern California we just had for BCF. But we basically want to be able to get people that may not be able to make a presentation in real life, or basically people that want to get a message out, like Thom here. And so we're giving him a platform to talk about what he's working on for the FujuNet project, and specifically the Coco and Dragon, but we'll talk about other stuff too if we have time. So we're trying to keep this to around an hour, so you don't have to dedicate a whole lot of your life. But we're basically going to roll here. So let me jump here to the full screen, and we'll let Thom take it away.
Hey everybody. So I'm Thom Cherryhomes with the FujuNet project. I am actually the chief firmware engineer for the FujuNet project. And basically where I am, so I'm Thom Cherryhomes. Pardon me, we've got people leaving in the background here, but I am actually they'll leave in just a moment. But all right. So basically, FujiNet is a network adapter for 8-bit systems. We started off on the Atari 8-bit, but we've expanded on to other systems as well. We've got about 6 machines that we've pushed to production. Most commonly, the Atari 8-bit, the Coleco Atom, the Atari Lynx, the Apple II, and others. But we're also doing bring-ups for many other systems, such as the Commodore machines through the IEC port, the RC 2014 recent retro-based systems, and way others. And as you can see right in front of me here on this phone video here, we have a TRS-80 Color Computer 2 that has a prototype version of the FujiNet that we've been working through here. And as a matter of fact, if I go ahead and turn on my handheld camera here, if it will let me do this, let's see. We can see this is the latest spin of the prototype Color Computer FujiNet board here. At the moment, it's using an ESP32 dev kit module. That's on top there. And we have on the bottom essentially a set of passive components, but we also have an LM386 amplifier kit that's used exclusively for the cassette server. We've got two connectors going out from this point here that go to the back of your color computer here. In my case, I've got a color computer 2. The cassette and the serial port, respectively. The cassette is used for bootstrapping, while the serial port is used for everything else. And in point of fact, the cassette color computer version of the FujiNet actually implements the drive wire protocol, while the serial port is used for everything else. And in point of fact, and you can see right there in frame, I actually have an HDB DOS cartridge here that I will be using for the majority of my demonstration here, since I don't think I want to have everybody sit through a cassette bootstrap. But you actually can do it. All you really have to do with a FujiNet attached and powered, if you have nothing else, you can use cload-m to load HDB DOS or DW3 load into your system so that you can use DriveWire. But in my case, what I'm going to do, I'm going to power you off for just a moment here. And I'm going to insert the aforementioned DriveWire cartridge here. I thought I could do this one-handed. Or do I have it? No, that's because it's upside down. Oops. There we go. So my phone seems to be a bit overzealous as far as autofocus is concerned. You can see that it immediately bounced into HDB DOS, and it immediately loaded a copy of the FujiNet configuration program off of the FujiNet's internal flash memory itself. Now, since this is a Wi-Fi network adapter, the first thing that it needs to do is to be able to take and configure to the network that you're currently have whizzing around your house. So in my case, I'm going to select my home network here, and I'm going to enter in my password for my network. And within a few moments, it will take and connect. And one of the things that turns on here is the is the white light here for the LED. And for some, oh yeah, it's because, hold on. We can see right here that we have our Wi-Fi indicator is now active here. We're now connected to the network. Now what can we do here? By default, when you were able to connect to a number of internet hosts, and these hosts essentially go into these host slots up here on top. I'm going to go ahead and use the edit feature here to add a couple of them. One of them is SD, and its whole purpose is to be able to access any disk images or disk images, programs, software, whatever that you may have stored on the SD card slot that's on the FujuNet itself. And we'll add another host here. That's an internet service, internet site called apps.errata.online here. And once we've done that, we can connect to that host. And what it will actually do is it will pull up a directory. I'm going to do that again because it timed out. There we go. It will pull up a directory of the root directory of that particular server. Now, by default, we use a protocol that we borrowed from the SpectraNet people called TNFS. And that software is actually available on our website, FujuNet.online. You can download a copy. You can run it on your local file. You can run it on your local network so that you can provide local network storage for all of your CoCos, or use one of the public file servers that are available, like this one. I'll go down to the CoCo directory here, and we will scroll down. You'll see that we have a couple of dots here indicating there's another page. We'll go to the next page, and we'll go into a folder that I've set up here called testing. And we have right here an example image here, in this case, Dragonfire. We'll select it, and we get the opportunity once we've selected it. We see some information about it, but we see an opportunity to take and place it in one of the 4 available device slots or drives, 0 through 3. We'll put it in the first one here. We'll select it, and once it's mounted, it'll take us back to the file selection screen so that we have an opportunity to take and select something else. We're not going to, so we'll just hit the break key here, and we come back to the host slot screen here. Other things that we can do include checking our network configuration. So we can see if we've connected to the right network, the address that it's given us, etc. And the IP address is important if you happen to be running on a network that doesn't give local host names to all of your devices, and you want to be able to connect to the web interface to take and do changes without having to come back into config or to pull printed pages from the virtual printer, that sort of thing. You also have the opportunity to take and change the SSID, so you can switch to another network, or you can reconnect if you've lost connection for some reason. If we come back, again, I apologize. It seems that my cell phone here is being very opportunistic about its autofocus here, and I cannot change that. I'm going to switch to another phone for future broadcasts. Anyway, so other things that we can do, if we press the left and right arrow keys, we can toggle back and forth between what's in host slots and what's in device slots. Really?
Yes, really.
This is driving me insane. So we can see right now that we have a copy of Dragonfire that is inserted. It's inserted read-only. We do this on public servers so that other people can take and mount these disk images alongside when we're doing them, and that we're mounting it from host slot number 2, which is the apps.errata.online. That's on this page. At this point here, we have other options as well. Again, you saw edit, but you also see there is a L to go to the FujuNet game lobby, which is a service that we're basically rolling out for all the FujuNet users to do multiplayer games and the like. You'll be able to take and load it directly from the configuration program. We'll go ahead and press the break key to quit. And once we do that, it will take and mount a copy of Dragonfire for us. And if we do a directory at this point, we'll see the Dragonfire is right there. Since we're running HDB DOS, we can basically do this. And in a few moments, it will literally take and load that copy of Dragonfire off of my server in the cloud directly to the CoCo here. And the CoCo is none the wiser. That's the virtual disk aspect of FujuNet. And it's something that pretty much anybody can use. Okay, so if I go ahead and reset at this point, it still has that disk mounted in the drive. Okay, no problem. If I take and press the reset button on the FujuNet, and then either do DOS or do a reset in this case, it goes all the way back to FujuNet config, so you can take and mount other disk images as well. Ooh, okay. Since I do not have an SD card in here, it's not saving the network configuration. So it's asking me for it again. It will not ask you for this again in production units at all. And yeah, okay. It wiped the configuration. No problem. I'll put it back. And again, anything that you can edit into a host slot corresponds to either a TNFS server, and we're adding in support for having servers serve from HTTP and a number of other protocols as well. All of that work is happening right now as we speak. But if we come back, oh, come on. Go back into our testing folder here. And we'll pull a copy of Nitros 9 here. Mount it right here into slot 0 again. And all the while this is actually happening, there is a bus indicator light that's flashing, indicating network activity. And of course, you have the Wi-Fi indicator activity as well. We can see right there, Nitros 9 is mounted. We'll go ahead and pull it in here. Okay, great. Now we can do DOS and find ourselves in Nitros 9. Now I'm putting ourselves here in Nitros 9 to demonstrate that if you have the drive wire support enabled along with the drive wire printing enabled, then you can also print to the virtual printer. And the best way we can do this to demonstrate is I will list the startup file. To the printer device. But before we do that, I'm actually going to take and temporarily just pull you to the side here for a second. so that we can actually take and show the web UI. Recall that our IP address was 192.168.1.4 from earlier, but you see right here a web view of what you saw in the configuration program. You see the host slots that we have configured, and we see the different devices that we have, the different disk images and things that we have mounted into drives. Okay. So at this point, I will take and I'll just select the Epson 80, which is MX80, FX80 printer emulation. And it will set that up. Pardon me while I look here real quick. Okay, so that's now set up here. So now, if I take and come back to our full screen display here, we'll go ahead and send to the printer. And it has now printed that to the printer. I'll close. And we can come right down here to download our printout. And we have right here a PDF. Take a look at it. Just a bog standard PDF file here. And we have here our printed output directly from OS 9. I would love to see this from other programs as well. But that brings me to the, honestly to the next part of all of this, because there's still so much left to be done. I'm only now bringing up the network device that will do all of the network socket communications as well. And I need to work with the color computer community here. Matter of fact, I think, let me take and open up my laptop here, and I'll do the rest of this from my, I'll do the rest of this from my camera here. Where is my Zoom? Almost there. Sorry. Where is chat record? There you are. Okay. So hold on. Pull that in here. So that brings me to basically to the part of my presentation here where I talk about what I need from the color computer community. Now that we have prototype boards that have been spun up and the hardware is relatively stable enough at this point, I would like to ask more people to take and join in to build boards and to not only help us test things as we bring up more bits and pieces of the firmware, but to also help us figure out a number of issues so that we can maximize the integration into the TRS-80 color computer world. Because on the Atari, for example, they have a well-defined device driver infrastructure in the form of CIO. So it was easy enough for us to basically take and write a network device handler that any Atari program could actually use, which would swizzle into a number of protocol adapters. So you could read and write a file from an FTP server or a web server, or take and just, or from a raw TCP or UCP, UDP client connection, expose all of those things very cleanly and very effectively. I'm writing a series of example applications. You guys may have seen the screenshots of those a couple of months earlier, the International Space Station tracker, the the weather program, etc. And all of those utilize the comprehensive network adapter firmware that's inside each and every FujiNet. The trick is to basically make it so that we can bring the features that are present in the FujiNet firmware and bring them out in for color computer users to use in a way that makes sense. But I'm not a native color computer user, so I don't know what users actually expect in terms of being able to take and expose these types of things. So I guess at this point, I guess I'll take and switch to a screen share here, and I'll show how things look on the Atari and even on the Apple II. So for that, I will share my screen again here, and we will go to a virtual machine that we have set up. And this is something else too. The color computer has a lot of great emulators. And what I'm about to show you right here is a virtual machine that we provide that you can, a virtual machine appliance that you can use and install yourself that has both the Atari and Apple II versions of FujiNet connected into emulators. And the way that we've actually done that is actually kind of cool because we've ported the FujiNet firmware to something that we call FujiNet PC. It's basically replacing all of the ESP32 stuff that's normally run on the microcontroller, those calls with standard POSIX and Win32 calls. So it's able to run the FujiNet firmware in the background as a process on your local PC that can connect to an emulator. Why would you want to do this? Well, very simply, it allows you to take and do FujiNet development entirely inside of an emulator to utilize the features of FujiNet inside of an emulator while also having access to the wonderful, and I do mean absolutely wonderful, debugging facilities that are present in emulators such as Altera and Applewin. So if I go ahead, let's say, some of the network applications that we have available here. The International Space Station Tracker. This uses the FujiNet network device to directly connect to a web service that provides a JSON document that shows exactly where the International Space Station is. It takes that JSON data, the FujiNet parses it directly, and then the target computer basically just queries for the relevant fields that it wants. In this case, the current latitude and the current longitude here. Conversely, I can do the same thing over here from Applewin for the Apple II. We connect to the same server here. And again, it's streaming these programs over as it's needing them. So I take and come over here. We were able to take roughly the same C code here and port it over and get the various versions of the International Space Station tracker running very quickly. So you can see. If I can get these kind of. Another example application is Mastodon. Mastodon is kind of interesting because it literally, I will take and use the web UI here to unmount this real quick so we can just go back to where we were. Oh, come on. Don't do that. Oh, don't do that. We're still getting this early version here. Darn. Figure out how best to basically handle this here. Hold on. Looks like the web UI for the Apple is not behaving. Why though? We have both of them running here. Okay, I'll take a different approach here. Let me take and restart.
Hey, Tom, I did have one question in the chat.
Yes.
Somebody's asking about we can't print directly to our own local printers if they have a local printer.
No. And there's
drive wire. Yeah, using drive wire. So you're tying up the serial port.
Yeah. So yes, and the reason we didn't direct. Yeah, there's no fundamental way to do that over. We decided not to basically implement any sort of network printing. And the reason was that network printing, even in the year 2024, is an absolute nightmare to implement. The openly available protocols are cumbersome to set up, and the ones that are easy to set up are closed off and require very expensive licenses. So what we opted to do instead was to render to a PDF that you could take and print using your printer, using your existing infrastructure. Because again, we can't directly connect to a printer like the traditional drive wire because there's no tether, and we can't support every conceivable way that you can connect to a printer over the network here. So we tried to find the easiest, most straightforward way to deal with that. And anytime any of you have any questions, please forward them over to me, and I will interrupt what I'm doing here to answer them directly. Some of the other bits and pieces that we have are things like the built-in virtual modem and the built-in CPM support. And basically from that point of view, we implement a complete, oh, you're not going to do that. Okay, demo jitters. We implement a complete Hayes compatible modem as a sub-device, but we also implement things like a complete Z80 based machine that actually can run CPM with file-based access on the cards, either on the SD card, and there's plans to actually be able to take and host volumes over the network as well. So does anybody else have any questions right now while I take and think about what else I want to take and show? Or maybe you can ask me something to take and pull this in a slightly different direction.
So Carrie on here on the chat asked about can't connect directly to an app on the local PC. And I was asking about clarification, what type of app? I mean, I assume if it's a type of TCP IP app that has, open support that you could reach out and connect to it if you wanted. But I'm trying to get some clarification from him, what type of app.
Yeah, it's like, so basically what we have here are a bunch of what we have here are a bunch of protocol adapters that we can take and connect to. Let me see if, oh
He said a
boy,
CPM that would talk to a real floppy disk.
what?
Yeah, that's what I'm thinking too. I guess he's thinking about if you have a host machine that has a real floppy disk, that being able to connect to it and then access that physical medium.
If someone wants to implement that, sure.
Yeah, right.
Well, you know, if you're trying to back up images, you know, and they were not corrupted in some way, you can just read them in a regular drive. That might be handy.
Yeah, perhaps.
So on
Let me-
on the color computer, a lot of times especially when you have your MPI, we'll have like a real floppy controller in one slot and the CoCo STC in another, or a drive wire. And so then you can basically, you know, access both devices. You can back up. You can either take a image through the drive wire, put it on the floppy, or vice versa. So
Okay.
maybe if you're looking for that type of thing, but not actually have a CoCo floppy.
Okay. That would be interesting if we could find a way to take and do that. And that's part of why I want to take and bring more people into the fold for this particular project, because I can only implement so much because I'm not
Yeah, you're not a
familiar.
CoCo person.
I'm not a
Yeah.
CoCo person, not natively, but I want to take and support as many different things as I possibly can. And to that end, that's basically why we've built the infrastructure that we have, so that we can basically take and so that we can take and make it so that if you don't have the hardware, you could still potentially use an emulator to take and do the requisite software development integration from that side of things.
So I'm probably not supposed to technically be here, but can I jump in with one?
Yeah,
quick?
go ahead, Rick.
So I make an Ethernet solution for the CoCo that's just that. It's just an Ethernet connection. You'd mentioned that FujuNet might have an HTTP interface.
That's the
coming,
yeah.
or-
Well, let me see if I can best explain what this is. So what we have in FujuNet is this gigantic microcontroller. It's many times more powerful than the machine it's connected to, ironically.
Right.
And on that microcontroller, the firmware that's running on it supports a whole bunch of different protocols. And just kind of a quick list. When you take and create a network connection using the network device, you can do it in TCP, UDP, FTP, HTTP, HTTPS, SSH, TNFS, NFS, SMB for Windows file shares, and so on. And what happens from the FujuNet's perspective, it is doing all of the heavy lifting to take and do all the protocol negotiation, while basically presenting a nice, clean I/O interface to the target system. For example, I will use the Atari version here, and we will just boot up a typical Atari disk operating system here, put it in slot 1, and we will boot to it. Oop. And I think I did that without BASIC. Let me pull that
So that's just
again.
loading up your server, or the one at the
Yes.
So
Yes, yes, all of that's being streamed off of the internet right now. None of this is local to my machine. Doesn't have to be. That's one of the nice things here. So we have right here a basic prompt here, and what I'm actually going to do, I'm going to open up another window here, just kind of to the side here, and I'm going to keep it on top so we can see it, and I'm going to open up just a socket here using Netcat. Port 6502, straight TCP here.
Of course.
Why not? Right? So I'm going to take and give myself some variable space here, because you have to do that in Atari Basic. Then I'm going to take and open up a connection here. And there's a couple of parameters here. The 12 is well known for Atari users to mean read and write. But the 2 here in this case basically says to translate the end of lines for line feeds back and forth between the ASCII end of line and the line feeds here. Does that for me transparently. And I'm going to open up my TCP connection here to TMA2 port 6502. And oh, come on. Yeah. Are we blocked off via NAT here? That's the thing. I'm doing this inside the VM here because I'm literally just blocked. I'm blocked away here. Let me see if I can do this inside my VM here. And as part of my updates that happened today, it blew away at least part of my wine setup. So
Yeah.
give me just a second. Do I have NC? Okay. All right, so there's that. Let's try that from inside here. Open tab. Let me take a look real quick at what my IP address is. Okay, 122.5. Try that again. And you can see right here, it's now made that connection. And at this point, I can use any of the standard IO functions to take and talk to it. It does it rather transparently. And of course, conversely, I can send something back. Vice versa. So the integration is such that it's very clean to be able to take and do to do network type things very easily and very effectively. So it doesn't matter based on the protocol that I take and put here. It doesn't matter if I am doing TCP or if I'm talking HTTPS here to rule.com, whatever. The FujuNet is taking care of doing all of the abstractions all by itself and just giving me a nice, clean information channel back and forth. And the one thing that I mentioned here, but I feel bears repeating, is that in addition to having the different protocol adapters, you have channel modes, which can transform the information in and out and redirect it to other things, such as a JSON parser, such as an XML parser. So you can open a connection and you can set the channel mode to JSON and send a command to say, I want you to parse this JSON, FujuNet, and I want you to take, and after that's done, it'll go, okay, done, I've parsed it. Because the FujuNet can take a massive blob of JSON and make mincemeat out of it much more effectively than the host computer ever could. You won't run out of memory, for one. And sorry?
Yeah, true.
Okay. So at that point, you can just query for the bits and pieces of information that you need in order to do that. Here, I'll give you another example here. Let's take, and I will cold reset this. And as part of that cold reset here, it actually took and closed the connection to that netcat that we had here. But I could have just as easily done close number 1 here. Anyway.
I have a question from Mikey. He may have answered it in a roundabout way here, but he was saying when he saw the first demo with the CoCo, he was trying to understand what was going on. And he said, for clarification, is the CoCo talking drive wire protocol to the FujuNet board, and then FujuNet mounts disks over the internet? And that was what you were doing in the very first demo? Okay.
Yes. So to that end, we've added a couple of additional opcodes as well. We've added one opcode that is opfuji, which is used to configure the network configuration aspects, which are basically like this. Yeah.
In band management.
basically network management here, but we also have an opcode for opnet, which is what's used to talk to the network device that's inside the FujuNet as well. And that handles all the open, close, read, write, and everything for the network side of it.
I had a question too. Have you seen the website frogfind.com?
Yes.
Yeah, I would assume this would work pretty slick with that.
It could. Yes, absolutely. What we opted to do, instead of trying to say, okay, we'll build a browser, was that pretty much every app, pretty much everything that we use today has some sort of web API that you can connect to, right?
Yep.
And because we can do HTTPS, because we have the SSL, the TLS, the crypto, and because we have the JSON and the XML parsing, that means we can do complex things like dealing with OAuth. That means combine all that together, and that means we can write front ends for all of our favorite web applications that we can use directly without having to take and swizzle that through a web browser of some sort, if that makes any sense. If we take and go back down here to internet, for example, we'll see very curiously that we have a Mastodon client here that I wrote in BASIC. And once we get to the basic prompt, we'll take and load that so that you can see what this is here. And you'll see it's not that much at all. That's it. That's all it takes to get the latest post from a Mastodon server, to parse it, to query for the individual pieces of information, and to display it. And then to wait roughly about 60 seconds for the next one. You can see right here that we're opening a connection to HTTPS here to oldbytes.space and their particular Mastodon server. And we're doing an API call directly. We're not using some sort of intermediate here. This is the important thing to understand. This is not some sort of intermediate. We're using the API directly. We take and we set our channel mode to JSON, and then we immediately say, okay, parse it. It's going to wait here for a moment until it actually finishes parsing the document. And then we take and query for account /0 account display name. These are XPath core. These are XPaths here, or JQ paths. Account created by, and each time we take, and once we pull that in, we use input to pull it into a variable, then we display it, and so on. And this is what it looks like.
So it's just to do a login, basically, or it's just to read a page.
Basically, it pulls the JSON for that particular server for the latest post. Since we did limit equals 1, that has the effect of basically getting the latest post.
All right.
So if I take and just quickly do this real quick, I'll show you the equivalent of what you're actually getting here. We'll pull that out. And I will go that's it. It's not word wrapping this, but you can see it's just pulling this in. I will take and pull this through a JSON formatter here so we can see. It's pulling the data for that latest post here. And we see we have a lot of fields that are coming through for just this one post. All sorts of stuff and all
Lot of
sorts of
overhead.
stuff. Yeah. Imagine having to take and parse all of that through the CoCo or the Atari 8-bit here. You'd run out of memory real fast.
Yep.
So all of this literally exists within the memory of the FujiNet. It parses that, and we send query information for all the bits and pieces of the information that we are interested in, and so on. That's essentially that's the next level power of the firmware that we have put together here. And the goal here for every single machine that we put this onto, this is what we're trying to get to. We're trying to get it to where it's easy to take and write software, and you could do it even in BASIC, like I've shown here. Let's see. Any other questions while I'm thinking of the next bit and piece here?
Somebody asked one about, is the CoCo online over? And I don't know if they're referring to like general internet activity or what. I mean, your tool basically lets you, like I said, do the heavy lifting to parse things like JSON, HTML, and HTTPS connections, so it can then deliver data to the CoCo. So it's acting as a proxy in that way, and that's really a good thing, obviously, because
Yes.
it's well beyond the abilities of a Atari or a CoCo or anything to actually do that itself.
Correct. And you can think of it literally, you can think of the FujiNet literally as a mainframe IO processor.
Front-end processor. Yeah.
Yeah. Yeah. And that's literally how input and output was done on mainframes for decades. So the point is yes, the system is online, except we've taken it and tried to expose things that are useful to the target machine, that makes sense for the target machine, and tried to present it in such a way that the target machine can grab the bits and pieces of the information that it's actually interested in, and to parse those things entirely at its leisure.
So thinking here, recapping, you're basically doing, you can do like remote disk mounting, just like you would through DriveWire. You can
Yep.
do generic TCP or UDP connections.
Yes.
But it can also, the FujiNet module can also handle an HTTPS connection or an NFS
Yes.
connection, network file system. SMB, which is server message block, which is a Windows server. What else you mentioned? Trivial NFS, which is the Spectrum one for
Yeah,
how you do
SpectraNet.
messaging.
That's
Yeah, SpectraNet.
we borrowed that from the SpectraNet people.
They already got it
And
figured out. So yeah.
yeah, so I mean, and there's plenty of firmware space inside the FujiNet firmware to add more firmware, to add more protocol adapters. And I would invite other people to take and explore to be able to do that. Our entire project is compulsively open. It's compulsively public. So we can do, so it opens up the possibilities for what you can do. Let me see if I'll brave doing this here. This is an example of just a basic little program. Again, I call it Netcat on the Atari 2 because it provides a basic terminal, but it's also a good example of how the protocol adapters and whatnot function on function on the FujiNet. Now, of course, I can connect to something like bbs.fostex.com here. I'll go ahead and set the translation to character turn line feed, no local echo. Username and password are used for certain protocol adapters to do in, like on the HTTP protocol adapter, it's not used for authentication. For it, you can put your SSH username and password and stuff here too. But we'll see right here that it's effortlessly taking and connecting to
Telnet BBS. Yep.
Mm-hmm. Yep.
Yeah, I raised Fostex. I recognize he's the one that took the TCP SIR that Jim Brain wrote and made some modifications to it so it runs smoother.
Mm. So you can see right here, this is it. This is working just fine. We'll go ahead, save. Okay, done. It's going to take and bounce back out again. But we'll turn right back around and we'll do something else.
How many apps do you have for the Atari so far? That's the first platform, so you're gonna have the most amount of integration with it compared to the others, right?
We have about, at this moment, we have roughly about a little more than a dozen different Atari applications. And yeah, that actually kind of reminds me here, since I finished this part here, we'll go to the lobby so you guys can see, for example, the game lobby and whatnot. So you can see what's intended there as well. So I'm going to take and go, come on,
We're coming
caps
up on an hour,
lock.
but we don't have anything after this, so let's just keep rolling. You've got definitely a lot
Okay,
of
yeah.
content.
I will keep going here because I really want people to get to bring the point across of what we're trying to do here. This is important.
Currently on the CoCo and Dragon, you only have about maybe a half dozen, 3 or 4 apps like the International Space Station and the
Hmm. So let me pull that here. Local area. No. Mm-hmm. So you can see right there, all I did was basically just change the protocol here, and now it's taking and pulling that particular document straight over HTTPS, and it did that transparently, and I did not have to change anything. I'll do one more netcat demonstration here.
Are you going to be able to get like a seamless protocol translation where you can fetch a page and it will determine whether it was JSON or XML or HTTP? Or
One of the things that you get from the HTTP protocol adapter is the ability to read the headers. You can read headers and you can inject headers to go back out for doing things like posts and for puts and things. That's all in how you interact with the protocol. So yes.
Cool.
So I'm going to see if I can do this here. The output may not make sense here for what I'm doing, but we'll try this anyway. Because I have a full screen terminal running here, so it might be kind of funny.
Yeah.
Come on, lowercase. You see what just happened right there?
You just SSH'd into your Irata Online server with
Yes.
Atari.
Yes. Transparently.
Yep.
It just works. Okay. So I'm going to go ahead and do a cold reset here.
So Mikey said, direct to you, Tom, he said that DriveWire really only provides block-based storage, object storage, virtual serialization, modem printing, time services. There really isn't any provision in CoCo, just extended killer basic for bidirectional serial port COM.
And that's been, and
that's been a problem.
Well, it's been an interesting way because I'm trying to take and find ways to reconcile the bits and pieces that had been added on to DriveWire since version 3 with what we've been doing with FujuNet, and I could use some help there. So that brings us to this little guy down here. You saw that on the CoCo version of the client here. This is the lobby. If you go into it, what you will see when you boot into it is a set of games that have published themselves on the internet using the API that the lobby provides. Since this is the first time I've logged in with this particular machine, it's asking for a username. It will take and put that username as an app key inside the FujuNet and retrieve it after that point. And we have right here a set of different games that are present on the FujuNet game lobby here. And the FujuNet game lobby is really nothing more than a publishing and subscription mechanism that any game can actually use to indicate, hi, I'm a game, this is what I am, this is how many players I can support, this is how many players are currently on a particular instance of the given game, and this is where my game is located. And in fact, if you actually go you can see the web facing front end of this, and you can read the documentation as to what's expected and things like, okay, figuring out for a given platform where to take and mount the appropriate game, all the fields, everything that's supported. But if we actually take and go into it, we'll take and pick a game right here. For example, I will take and boot in. And now it's loading a copy of 5-Card Stud that connects to what's known as the green room for 5-Card Stud. And this is a room that has 6 robot players and has allocations for 2 human players. The 5-Card Stud game itself does all of its own server interaction, takes care of all of that itself, and it just talks to the lobby to indicate whether or not it has room for players or not, that sort of thing. Players join, players leave, that sort of thing, and all of that gets bubbled back up to the lobby server. But you can see right here we have a nice little game of 5-Card Stud being played between multiple participants. And with the FujuNet lends itself very well to turn-based games. And we're taking and porting this. We've got here on the Atari 8-bit, but we're porting this to all of the platforms that FujuNet currently supports. This includes the CoCo as well. And we can do this because the core client itself is actually not only very simple, but we've written it in C, so it can be taken and brought over to all these different platforms very simply and very effectively. And I hope this actually opens up, get some of you thinking, because FujuNet in and of itself is much more than just this hardware enabling device here. What I'm actually trying to do is to facilitate cross-community cooperation and bringing people together, because for far too long we've been sitting off in our own little corners for decades, not really aware of what all these other communities are working on or doing. And I'm trying to get it to the point where we can look over at the fence and see what the other communities are doing, but also create a sort of gravity well that will pull people in and get us working together on something new and interesting.
So if people wanted to start developing for FujuNet for the Dragon or the CoCo, you could use like the International Space Station or one of these others as a template, or do you have like
Yes. To that end, we have a number of repositories. Of course, if you go to fujunet.online, you'll see our main website, which has not only the latest news that gets posted up here, you'll also have the ability to take and get a FujuNet. You'll be able to get support, but you have connections into our GitHub. And our GitHub is basically split up into a handful of different repos. We have the firmware, but we also have a number of FujuNet applications written for the various different machines, showing off all of the different things that can be done. And there's a wide variety of different applications that were written here. We did, as a quick thing, we did an election tracker back in 2020, or there is a real-time clock driver that uses the real-time clock that's inside the FujuNet firmware and exposes that to ProDOS. and so on and so on and so on. You can see, for example, there's the ISS tracker. And we have and you have different folders for different targets of the ISS tracker here. The goal here is basically to be a Rosetta Stone so you can see how to take and implement this ISS tracker using a wide variety of different machines so that you can take and essentially do that.
Okay, I guess you've thrown the gauntlet down. So people need to get the hardware. They need to order up the
Mhm.
board and get the module. These little
Yep.
ESP32 Dev Kit VEs. I actually ordered a couple. They're about $11 each on Amazon.
Mm-hmm.
And
And yep, I don't have the links for that entire here yet, but Chris Trustig uh, has the current schematic for the current and the schematics, bombs, Gerbers, etc. for the current version of the hardware, which I know that you have. So please try to get that out so people can get to it. But it will also be available
to purchase as a completed unit.
to purchase as a completed unit, but also for every single FujuNet that we pull into production, these get put into our hardware repos as well, so that any vendor can actually take and build these for the target community, because that's essentially the way that we work. We don't build them ourselves. Instead, we try to work with the vendors in each target community to be able to take and to be able to have them available for each of the target communities.
So on the CoCo, you're building a cartridge port version, which I assume will also work for the Dragon as well.
That's going to be interesting because, as far as I know, the cartridge port on the Dragon is not exactly the same, but we'll cross that bridge when we get to it.
It's there's a few things with interrupts, like with drive controllers, like the SDC, which is the SD card solution for the CoCo and the Dragon, has to have some changes to operate at the physical level. The cartridge is the same; it's wired basically the same, so you
Okay.
don't have to like it's don't have an adapter or anything. But the as I remember, the floppy disk control I think uses a non-maskable interrupt on the Dragon, but not on the CoCo. So there has to be a couple minor hardware adjustments, but that can be done on the board with a physical switch.
Okay.
And then other than
Well,
that, you just have to have the right ROM for do you want to do Dragon DOS or you want to do CoCo's DOS.
yeah. That brings me to another point too. One thing I didn't bring up with the CoCo interface here, we actually wired up the carrier detect port on the serial port for the express purpose of using its IRQ to indicate whenever network traffic is available, so you're not constantly having to pull it. We do the same thing on the Atari 8-bit, for example, using its interrupt pins.
Okay, well,
Um,
anyway, people need to get the hardware, and then anybody that's
let's
programming.
and yeah, need to get the hardware and to talk with us in our Discord. Uh, I can take and provide links to our Discord, and I am also available in the CoCo Discord as well. There's a channel called #FujuNet that I also am a part of too and receive notifications from. So if anybody has any questions, they can ask me there as well. But in case it wasn't immediately evident, I don't just want the versions of the FujuNet these for these emulators here. I would like to see the requisite Cola computer emulators also take and use the work that we've done in FujuNet PC to to connect FujuNet PC into XROR or VCC or that sort of thing.
Do you have some templates or guides for that too for the people that maintain our emulators?
That's something that we're putting together now. For right now, the best way is to come by and to talk with us. It may very well be that we just say, you know what, we'll emulate the Becker port. We'll see what happens.
Huh. Yeah, that's been the solution so far.
So it's yeah. It's like, again, the big fundamental difference for most color computer users is literally going to be, well, it's drive wire without the tether. That's something that they can pretty much use immediately. But then you have access to all of these all of this network functionality, offloaded network functionality. That's something new that we bring to the table as well, and the virtual printer. So.
Well, I think we answered most of the questions, at least what I can understand from them. Is there any final questions from anybody that's watching this stream? Oh, Carrie again asked, no support or plans for supporting the TRS-80 models 1, 3, and 4, those with the Z80 based Tristos CPM style.
Okay, guys.
Hmm.
When I said that we want to take and support every single computing and game console platform, retro computing and retro gaming console platform on planet Earth, we meant it.
Meant everything. Okay.
I meant
it's in the queue then. It's in the queue.
It's all about, and this is the important thing. I'm able to do this. I was able to do this bring up because A, I got access to the hardware, and B, we had enough information to start a bring up.
Right.
For anybody that's interested and wants to see FujuNet for a target system, at minimum, that's what we need. We need hardware, and we need the requisite information to take and integrate into wherever we can possibly integrate into. But even better are people that would want to come in and to champion the particular bring up and to do the work while we take and help them along with the integration. This is what's happening with the RC 2014 port. It's what's happening with the ZX Spectrum port. It's what's happening with the Atari 2600 port that just came up a couple of days ago, and so on and so on. People are coming in and they're taking ownership of the platform that they want to see happen. That's what, and so this is an open and a public project. So if you can help, please come in and help.
And again, the website is fujinet.online to get a hold of you. Okay, good place to start. They also have a FujiNet Discord. I'm a member of that, and I'll get all these links from you. I probably have most of them already, but I'll get them all posted and added to the stuff. So
yeah, and we even so all the information that you need. So, and join the Discord, bam, and so there you go. It's all there. So okay.
Well, thank you for coming on. We've gone a little bit over, but this is a great area. I enjoyed talking with you previously when we had you on the CoCo Talk, when you did Errata Online and Plato System, which is another cool thing too. And
yes.
Anyway, and I know you still have that up and going. And anyway,
yes.
So any final questions? Oh, where does the name come from? FujiNet, probably?
FujiNet. Well, originally when we started, when we were just going to be an Atari network adapter, we were called Atari Wi-Fi. And Jason Scott, some of you know him as Text Files, one of the Internet Archive people, politely tapped me on the shoulder and said, Atari is getting a little litigious happy lately. You might want to change the name. So since the Atari logo has a vague resemblance to, say, the snow cap of Mount Fuji, we opted to go with the name FujiNet. It was something that Kay Savitz came up with, and it stuck.
Recognizable, and but not something that could be copyrighted per se.
Yes.
Excellent. Did we get most of everybody's questions? I hope I understood all of them people were sending.
Let me see if there's anything. I think, yeah. Okay. Well, again, if anybody has any questions, please feel free to take and hit me up in Discord, hit me up on Facebook. I'm constantly up here, and ironically, I spend a huge chunk of my time now basically on social networks just trying to get this out there. And I appreciate you giving me the time to take and show and demonstrate what this thing can do.
Glad to get the message out. That's what we're all about. The CoCo Nation is all about trying to reach out, connect the community, and get people involved to stuff. So we try really, really hard. That's why we do a weekly stream every week. So,
okay.
Glad to have you here. Well, thank you
Okay.
for the virtual fest, and you're the first one, and we'll probably be talking to you in the future. So,
Sounds good.
okay, I'm going to call this a wrap. And tomorrow morning, morning for me, it'll be 6 a.m. It'll be 9 a.m. Pacific time. We're going to have Julian Brown, who's a dragon guy. He actually built a Dragon 32 reproduction board from ground up in KiCad. And you can buy those and then buy all the parts and put it together. He's got a lot of other hardware stuff too. So he'll be my 1 hour guest tomorrow. Anyway, thank you much. And we will pick this up tomorrow. Thank you very much again, Thom, for coming on board. And I really like your projects.
Thank you.
Goodbye, all. Call this the end.